Dear students, welcome to the problem solving session on inverse Z transform using convolution theorem. In the previous videos, we are solving inverse Z transform using partial fraction method as well as residue method. Those who don't watch the videos, go to the playlist, watch that video and come back here. In this session, we are going to learn how to find inverse Z transform using convolution theorem. Before going to the problems, let us know the definition of convolution and convolution theorem. Let f of n and g of n be the two given sequences. The convolution of two sequence is given by the notation star. So f of n star g of n is equal to r equal to 0 to n f of r into g of n minus r. And we have very important property for convolution, that is it satisfies commutative property. That means f of n star g of n is equal to g of n star f of n. Next, from the definition of convolution, we can write the convolution theorem. If z of f of n is equal to capital F of z and then z of g of n, we assume it as capital G of z, then the convolution theorem is z of f of n star g of n, that is z of f of n convolution g of n is equal to capital F of z into g of z. But we are not going to use this formula. This is for MCQ. We are going to use the inverse. So z inverse of capital F of z into g of z is equal to z inverse of f of z star z inverse of g of z. Here this star represents the convolution. And now, do you remember the geometric series formula? 1 plus r square etc. r power n is equal to 1 minus r power n plus 1 divided by 1 minus r. Similarly, sometime we can write this as a. This formula is going to be useful for solving inverse Z transform using convolution theorem. Let us go into the problem. Very important, student. If they simply give solve or find Z inverse, then you are free to do in any method. Either you can use partial fraction or residue method or convolution or long division, etc. etc. If they mention very specific like this problem, evaluate using convolution theorem. C dot T represent convolution theorem. I don't have space, so I just write in a short form. Then no other go, you have to use the specific method and you have to solve. Just write the convolution theorem formula first and then convolution definition next. Now we have Z inverse of Z square by Z minus A into Z minus B. This can be splitted as Z by Z minus A into Z by Z minus B. It looks like Z inverse of capital F of Z into G of Z. Now applying convolution theorem or simply write by convolution theorem, this is equal to Z inverse of F of Z star Z inverse of G of Z. Now substitute the value. F of Z is Z by Z minus A, G of Z is Z by Z minus B, and we know that Z inverse of Z by Z minus A is going to be A power n. So the answer is A power n star B power n. But still it is in the form of convolution. So I want to simplify further. So I will take this as f of n star g of n. Now by the definition of convolution, f of n star g of n is r equal to 0 to n f of r into g of n minus r. Now apply this formula for a power n star b power n. I can write this as a power r into b power n minus r. Now I can split this into r equal to 0 to n a power r b power n b power minus r. This b power n is no way connected with problem, so I can take this outside and now I can write the remaining as a by b whole power r, because b power minus r is 1 by b whole power r. So combining this two will be getting like this. I'll show the typed version. Now expanding this b power n 1 plus a by b, because when you put r equal to 0, a by b whole power 0 is 1, plus a by b whole square etc. We have finite number of terms up to n. From the geometric series formula, I can write this as 1 minus a by b whole power n plus 1 divided by 1 minus a by b. Now taking LCM, will be getting b power n plus 1 minus a power n plus 1 divided by b. In the denominator, we have b minus a by b. We can see the typed version. Now, simplifying this by taking this b to the numerator, now b power n plus 1 will get cancelled with b power n and b. Therefore, my final answer is b power n plus 1 minus a power n plus 1 divided by b minus a. So, z inverse of z square divided by z minus a into z minus b is equal to b power n plus 1 minus a power n plus 1 divided by b minus a. How we can achieve this? If you take minus outside, it will become a power n plus 1 minus b power n plus 1 divided by a minus b. Now this minus minus get cancelled, will be getting the result. Both are same. Either you write b first or you write a first. Answer is going to be the same. Next, in exams, they will ask you to find z inverse of z square by z minus 1 into z minus 3. So, my kind suggestion is don't solve for numbers. We do error. So, just assume z inverse of z square divided by z minus a, z minus b. Once you assume this, then start deriving the answer and write like this finally. Now, go to the question. The given question is z inverse of z square divided by z minus 1, z minus 3. Comparing the question with my derived value, my a equal to 1, b equal to 3. So now substituting the values of a and b in the formula, will be getting 3 power n plus 1 minus 1 power n plus 1 divided by 3 minus 1. 3 minus 1 is going to be 2. 3 power n plus 1 minus 1, because 1 power anything is going to be 1. Next, they can ask some problems like this. 8z square divided by 2z minus 1, 4z minus 1. Now, students will do some errors. They will derive z inverse of z square divided by z minus a, z minus b. Now, in somehow small confusions, they will take a equal to 1, b equal to 1 by seeing the question in an improper way. A and b are 1. It should have like z minus a, z minus b, but this is not in that format. So I am going to take this 2 outside, then it will become 8z square, 2 into z minus 1 by 2. In the second term, I will take 4 outside, z minus 1 by 4. So now 8 and 8 will get cancelled, will be getting this. From this, I can derive the general formula from example 1. Now I can identify a equal to 1 by 2, b equal to 1 by 4. Now substituting the value, will be getting 1 by 4 whole power n plus 1 minus 1 by 2 whole power n plus 1. 1 by 4 minus 1 by 2 is going to be minus 1 by 4. Now take the first term, 1 by 4 whole power n plus 1 divided by minus 1 by 4. I can rewrite this as 1 by 4 n plus 1 minus 1. So it is going to be minus 1 by 4 n. Next term, minus 1 by 2 whole power n plus 1 divided by minus 1 by 4. I can write this as minus 1 by 2 whole power n plus 1 divided by minus 1 by 2 whole square. So minus minus get cancelled. When this go to the numerator, we'll be getting 1 by 2 n plus 1 minus 2. So we'll get the final answer plus 1 by 2 n minus 1. This is my final answer. You can stop here.
Thanks for watching. Subscribe to our channel and share to your friends. See you in the next video. Bye bye.